Imagine stepping outside at midnight. You expect quiet darkness and street lamps. Instead, the sky is suddenly glowing brighter than a full moon. That light isn't coming from the moon. It's coming from Jupiter. In a single moment, the largest planet in our system began emitting its own light, acting as a second sun. Across the globe, the immediate reaction is pure awe. People pour into the streets to celebrate, children cheer at the sudden double sunrise, and social media declares it the most beautiful night in history. But inside observatories, that awe quickly turns to dread. Astronomers realize that if this ignition is permanent, the cycle of day and night has been permanently broken. We may have just seen our last true sunset. To understand how this happened, we have to look at what Jupiter is made of. Astronomers call it a failed star because it shares a nearly identical molecular profile with our Sun, mostly hydrogen and helium. In this thought experiment, an unknown cosmic event delivers a sudden, massive surge of energy to Jupiter's core, forcing those gases to ignite and begin producing their own luminosity. Instantly, the inner solar system is flooded with a second source of massive radiation. Shadows on Earth shift, and the moon is outshone by a distant orb that never sets. By adding a second energy source to our planetary system, we've triggered a shift that Earth's biology has had no time to adapt to. The first few weeks feel like a strange, endless summer. People play football at midnight, mountains glow under two stars, and major cities simply switch off their streetlights to save power. But the honeymoon ends as the ecological cost becomes clear. Nocturnal predators like owls, which rely on the cover of darkness to ambush prey, can no longer hunt effectively. Their success rates plummet, leading to rapid starvation. Migratory birds that navigate by the stars become disoriented, flying in circles until they collapse. Hatching sea turtles, which instinctively move toward the brightest horizon to find the ocean, wander inland toward the glowing Jupiter and never reach the water. Darkness is more than a lack of light. It is a biological requirement. Without it, the evolutionary rhythms that hold Earth's ecosystems together begin to unravel. The physical planet begins to respond as well. With constant light from two directions, Earth can no longer shed heat at night. Temperatures rise, and the polar regions receive relentless energy that accelerates the melting of ancient ice. Space agencies like NASA are forced to react instantly. They shift their focus away from the inner planets, launching a massive wave of missions toward this new source of energy. On Europa, the sudden influx of star-level energy begins to soften the moon's thick ice crust. While the radiation is intense, the heat introduces the possibility of accessing the liquid water oceans hidden beneath the surface. Even further out, moons like Callisto lose their permanent deep freeze. The massive increase in ambient energy provides a logistical power source for scientific colonies that were previously impossible to sustain. This pivot forces a complete rewrite of our mission goals. For the first time, our exploration isn't limited to our own sun's reach. We now have a second focal point for the future of our species. But these scenarios rely on a specific assumption that the laws of physics aren't ready to grant. This data shows the problem. Jupiter possesses only 0.1% of the mass needed to become a star. To reach nuclear fusion, you would need to crush dozens of Jupiters together until they reach critical density. A second sun cannot simply turn on. To get the light, you have to find a way to inject a massive amount of physical matter into the system. This is where the thought experiment becomes a catastrophe. If Jupiter suddenly gained enough mass to become a star, its gravitational pull would increase by an order of magnitude. As this map shows, that massive new gravity well would reach across the solar system, pulling nearby planets out of their stable orbits and tearing moons directly into the new star. The delicate architecture of the solar system would be ripped apart. Earth would be thrown into a chaotic new trajectory, making it uninhabitable long before we could even enjoy the view of our second sun. You cannot have the light without the gravity. In our universe, a second sun isn't a miracle, it's a wrecking ball. It brings us back to the quiet shadow that falls across our planet every single evening, a part of our lives we rarely stop to value. Without true night, we lose our connection to everything beyond our own neighborhood. The constellations, distant galaxies, and the Milky Way would disappear behind a constant artificial glow. Perhaps the greatest gift our solar system gave us wasn't just the warmth of the sun. It was the balance between light and darkness. If you had to choose a world with two suns or keep the night sky, tell us in the comments and subscribe to Future Decoded for more deep dives into our solar system.